Chlorophyll is the green pigment that makes green leaves green. If one searches for chlorophyll in the medical literature, though, a lot of what you find is about fecal fluorescence, a way to detect the contamination of carcasses with feces in the slaughterhouse, to reduce the risk of food poisoning from pathogens harbored within animal feces. See, fecal matter gets on meat either through with knife entry through the hide into the carcass, and also splashback and airborne deposition of fecal matter when you're peeling off the skin. But if they've been eating grass, you can pick up the poo with a black light. Here's a solution of chlorophyll. Under a UV light, though, chlorophyll lights up as red. So if you have a black light in a chicken slaughter plant, you can get a drop on the droppings. The problem is we don't let chickens outside anymore, right? They're no longer pecking at grass, so there's less fecal fluorescence. We could let them run around, but it would save money. Just add a chlorophyll supplement to their feed, so then you can better identify the areas of gut spill contamination on the meat. The reason I was looking up chlorophyll was to follow up on the data I presented in my Eating Green to Prevent Cancer video, suggesting that chlorophyll may be able to block carcinogens. There were a few in vitro studies I found, in addition, on the potential anti-inflammatory effects of chlorophyll. After all, green leaves have long been used to treat inflammation, so anti-inflammatory properties of chlorophyll and their breakdown products after digestion was put to the test. And indeed, they may represent valuable and abundantly available anti-inflammatory agents. Maybe that's one reason why cruciferous veggies like kale and collard greens are associated with decreased markers of inflammation. In a petri dish, for example, if you lay down a layer of arterial lining cells, this is how many inflammatory immune cells stick to them before and after you stimulate them with a toxic substance. We can bring that inflammation down, though, with the anti-inflammatory drug aspirin, or even more by just adding some chlorophyll, just dripping some chlorophyll on it. Perhaps that's one of the reasons kale consumers may live longer lives. This is the study, though, that blew my mind. Sunlight is the most abundant energy source on this planet. So far, so good. However, only plants are able to use it directly, or so we thought. After eating plants, animals have chlorophyll in them too, right? Might we be able to derive energy directly from sunlight? What? OK, first of all, light can't get through our skin, right? Wrong, as was demonstrated by century-old science and any kid who's ever shined a flashlight through their fingers. Right? The red wavelengths do get through. In fact, if you step outside on a sunny day, there's enough light going through your skull into your brain you could read a book in there. OK, so our internal organs are actually bathed in sunlight and absorbed chlorophyll, right? When we eat green leafy vegetables, in our body does actually appear to produce cellular energy, but unless we ate so many greens we turned green ourselves, the energy produced is probably negligible. However, light-activated chlorophyll inside our body may help regenerate coenzyme Q10. CoQ10 is an antioxidant our body basically makes from scratch, using the same enzyme that our body uses to make cholesterol, the same enzyme that's blocked by cholesterol-lowering statin drugs. So if CoQ10 production gets kind of caught in the crossfire, then maybe that explains why statins increase our risk of diabetes by accidentally also kind of reducing CoQ10 levels in this kind of friendly fire event. Maybe that's why statins can lead to muscle breakdown. So should statin users take CoQ10 supplements? No, they should improve their diet sufficient to stop taking drugs that muck with their biochemistry. And by doing so, by eating more plant-based, kind of chlorophyll-rich diets, they may best maintain their levels of active CoQ10, also known as ubiquinol. However, when ubiquinol is used as an antioxidant, it's oxidized into ubiquinone, and to act as an effective antioxidant again, the body must regenerate ubiquinol from ubiquinone, maybe using dietary chlorophyll metabolites and light. So they put it to the test. They exposed some ubiquinone and chlorophyll metabolites to the kind of light that makes it into our bloodstream, and poof! CoQ10 was reborn. But without the chlorophyll, or without the light, nothing happened. And look, we got light, we got chlorophyll for eating our veggies, right? So maybe that's how human beings maintain such high levels of CoQ10 in our bloodstream. Maybe that explains why dark green leafy veggies are so good for us. I mean, we know sun can be good for us, we know greens can be good for us, but these benefits were commonly attributed to the increase in vitamin D from sunlight exposure and all the antioxidants in green vegetables, but maybe these explanations might be incomplete.